let's have a look at the idea behind factorising. Factorising, the first time you did factorising, you probably didn't call it that. The first time you did factorising is when you got numbers and you broke them down to their prime factors, and you said things like, 12, that can be rewritten as 2 squared times 3. That's factorising. You're writing it as factors. That's exactly what we're doing with algebra. We're breaking it down to all the multiples, back to its basic factors. So, first thing, always look for the common factor. It's the easiest one to look for. So if it's there, drag that out first. Then the number of terms will give us an idea of what strategy to try. If it's got 2 terms, is it the difference of 2 squares? Could it be the sum and difference of 2 cubes? Those sorts of things we're looking for. 3 terms. Okay, it's 3 terms, trinomial. Is it a quadratic? Can I solve it that way? 4 terms. I'm probably going to try grouping in pairs. Try and do a bit at a time and hopefully it'll work out. So that's the sort of thought process I'm going through. So first of all, common factor. Remember, factorising is dividing by that common factor. That's all it is. You're just dividing. Tricky. AX plus BX. What do they have in common? Oh, it's the X. So we factorise out the X. Sometimes people get hung up with what's in, well, not so much with this one, of course, but what do I write down in the parentheses? Remember, it's just division. You get each term divided by the factor you took out. So AX divided by X is A, so I write A down, and BX divided by X is B, so I write B down. It's a basic idea, but we keep using it all the time. So 5x squared minus 10x, the biggest mistake here is to take out one common factor, but in fact there's 2. I mean, you've got the 5 and the x. So we take out 5x and I'm left with x minus 2. Okay. Whoa, 4 terms. Why is that in common factor? Well, grouping in pairs, common factors, it's really the same idea. Because when you look at this, m's in 2, it's only in 2 of them. X, it's only in 2 of them. N, no, it's only in 2 of them. Y, it's only in 2 of them as well. So I can't find a common factor in them all. So I'll break it down and look at them in pairs. So if I look at the first 2, I go, yeah, look, it's got a common factor of x, and so does the second one, has a common factor, but y. You'll notice I took out the negative factor though, because what we want to do with grouping in pairs is leave the same thing in the parentheses in both, because now I can really look at this question and say, I've got 2 terms, and they have a common factor of m minus n. So m minus m, n, I'm dividing, so I'm left with x and minus y. Bingo, there we are, grouping in pairs. Okay, difference of 2 squares. Remember, it comes from that idea, but it's just going back the other way. So if I see a squared minus b squared, I know it'll be a plus b, a minus b. Or the other way around, doesn't matter, because multiplication you can do in any order. 16x squared minus 1. 16x squared, that's 4x, and 1 squared is 1, so 4x minus 1, 4x plus 1. 3, 3 is not a perfect square, neither is 75. I suppose I could write it as root 3y plus root 75, root 3y minus root 75, but in this case that would be rather stupid. Because what should I have done? Right, go back to rule number 1. Always look for the common factor. Take out a common factor of 3, and then it becomes a lot easier. Y squared minus 25. And so we have y plus 5, y minus 5. Okay, hang on, 4 terms. Here we go again. Okay, x, no, 5, geez, y, no good. Okay, well, let's try it in pairs. By the way, you don't have to pick the first 2 and the second 2. You can pick any pair you like. You might go down the wrong path. That's all right. I mean, if it doesn't work, try a different pair. If I do the first 2, it's 5x minus y. The second 2, difference of 2 squares. And now these 2 things have a common factor of x minus y. So there we go, x minus y, 5 plus x plus y. All right, let's have a look at good old trinomials. I know that if I expand out x plus a, x plus b, once I expand out and group like terms, I'll get x squared plus a plus b, x plus ab. This is why when we look at a trinomial, we say what two things multiply together to give the last number, add together to give the middle number. If I find those numbers, I can go back to the factorisation. So all right, here we go. Multiply 18, add to give 9. 6 and 3. Well done. So yes, yes. So x plus 6, x plus 3. Oh, it doesn't have to be x. Works with t as well. Multiplies to give 3, adds to give... Oh, hey, here's interesting. Adds to give a negative number, multiplies to give a positive number. That tells me we're looking at two negative numbers. So all right, negative what and negative what will work here? 3 and 1. Makes it nice when they give us a prime number. There's not a lot of choice, really, is there? So, negative 3, negative 1. Whoa, hang on, there's two letters. What's going on? You still do it the same way. Think of it in terms of just x. And so what I'm really saying now is what multiplies together to give 4y squared, what adds together to give negative 5, but the reality is I don't even have to worry about the y. It's still just the number is the key. Multiplies together to give 4, adds together to give negative 5. But the difference is, instead of writing negative 4 and negative 1 down, I write negative 4y and negative 1y down. Now, I could have just as easily have done that by making it a quadratic in terms of y. Of course, it wouldn't have been monic then, so it makes it a little bit harder. So if I've got a choice, I'll go with the monic. Always easier to factorise the old monic. Splitting the middle for when it's not the monic. There are lots of different ways of doing ones that are not monic. Cross method is probably the most common. Is that the way you guys were shown, cross method? Okay. My personal favourite is splitting the middle. And the reason I like splitting the middle is it still keeps that same idea of what multiplies together to give a number, adds together to give a number. So I see something like this. It's not monic. So instead of saying what multiplies together to give negative 7, I'll multiply that constant by whatever the coefficient of x squared is. So it multiplies together to give negative 21. Still adds together to give 4. Okay. Multiplies together to give negative 21. So we're talking about a positive number and a negative number. Add together to give 4. What do we got? Okay. So we got 7 and negative 3. And we split the middle term into those two. So the 4 becomes negative 3 plus 7, and it becomes a grouping in pairs question. So if I group in pairs the first one, I get 3x outside of x minus 1. The second two, I get 7 outside of x minus 1. Has a common factor of x minus 1, 3x plus 7. Okay? So that's what's called splitting the middle. Let's try another one. So instead of saying multiplies together to give negative 12, we're going to say negative 24, because that is 2 times negative 12. Multiplies negative 24, adds to give negative 5. Again, we're talking about a positive and a negative. Factors of 24, difference of 5. Anyone? 8 and 3, and the bigger one's got to be negative because we end up with a negative. So split the middle. It actually doesn't matter whether I split it the other way. I could have gone plus 3x minus 8x. It still would work. Group in pairs. And there we go. So that's a different way. Now, if you've never tried splitting the middle, maybe in some of these questions, just have a go at it. And then you can make a choice for yourself. Do I prefer this method or do I prefer the method I'm used to? You never know. You might find this an easier way than what you're used to.